Hello, today we're going to take notes 4 called multi-step equations. So far we have been working on 1 and 2 step equations. This is an example of a 2-step equation. Remember, it's a 2-step equation because there's 2 numbers on the side of the equation with the variable. There's a 9, that's the constant, and the 3, that's the coefficient. This is an example of a multi-step equation. You can see that there are lots of numbers and letters with on either side of the equation. There's variables on both sides. It's just more complicated. That's why it's a multi-step equation. There's multiple steps. So at the top of your notes, make sure it says notes for multi-step equations. I have 4 steps that we're going to try to go through each time. I'll show you those, and then we'll do 2 examples, or 3 examples, excuse me. So the first thing you're going to do each time you approach a multi-step equation is you're going to add the opposite. That means you're going to get rid of the subtraction sign. We're going to try to work only with plus signs. It'll end up being that we have some negative numbers, but it just makes it easier. We won't forget if something is negative if we add the opposite. The second thing we're going to do is we're going to distribute and simplify each side. Each side of a multi-step equation is its own little expression, and our job is to simplify the expression on the left, simplify the expression on the right, and then solve from there. The third step is you're going to get all the variables on one side. Like that previous example, there were x's on both the left and the right side of the equation. We have to move one of the variables to the other side, and I'll show you how to do that. And then the last step is you're going to get rid of the constant and then the coefficient. Step number 4 is where we have been practicing with 2-step equations. If you simplify or do the problem all the way out, you should be left with a 2-step equation at the end. So we always get rid of the constant and then the coefficient. Let's try some examples. I wrote the steps out right here just so we can follow along, but here's our first example if you can copy that down. I always, again, start by drawing a line through the equal sign. And then I look, is there any subtraction? Can I add the opposite? And if I look here, they're all addition signs. Second step is we're going to distribute and simplify. I am only looking at the left side of the equation to start. There's no distributive property, but I do have like terms. I have a 2x and a 3x. So I'm going to put those together. 2x and 3x is 5x's. And that 4 just stays there. So I simplified this side. Then I'm going to look, can I simplify this side? Is 10x and 14, are we able to put those together? And the answer is no. So I'm just going to copy those down. Some of you don't like to show your work, but it is critical to be successful in solving these problems to show your work. This is not one where you can just try to figure out what the answer is. You have to have evidence. So we added the opposite and we simplified each side. There's nothing else to simplify over here. There's nothing else to simplify over here. And now my next step is to get all the variables on one side. You see how I have a 5x and a 10x, one on the left and one on the right? My job is to move one to the other side. To do that, we're going to take it away. I recommend always taking away the one with a smaller coefficient. So to move a 5x over here, I'm not just going to like pick it up and plop it down. I have to take it away. The reason I'm taking away is because 5x minus 5x is 0. Now they're gone. And if I take away 5x from this side, I have to do the same to this side. And I'm going to put that 5x in a very specific place. I put the 5x underneath the 10x. And the reason is because those are like terms, and I can do the math with that problem. I could not do 14 minus 5x because they're not like terms. So I stack the x's together. On this side, I'm left with 4. This, I have 5x if I do that math, and then that 14 just stays there. I got all the variables on one side. Now I need to get rid of the constant and then the coefficient. I'm looking at the side with the x. The constant is the 14. So I'm going to take away 14. Take away 14. 4 minus 14 is negative 10. And a 5x is left. So then I have to get rid of a times 5 by dividing both sides by 5. And I'm left with x is equal to negative 2. Like this is an x and negative 10 divided by 5 is negative 2. You can flip that around to have the x first, but my answer is negative 2. If I wanted to check my work, I could replace every x